Okay, everybody, this is chapter 5, lesson 1, and I'm kind of using the old recording device here, so sometimes the right-hand side gets cut off. Just try to listen to my voice. Use your book to kind of see what the whole picture should say, and then I'll try to write as much as I can to the left-hand side and write small. Once again, if you guys are getting, if I'm going too fast, hit the pause button and get caught up with your notes, then let's hit play and get moving, okay? So I apologize for the quality here, but I just got to make sure that you guys get this, okay? If we're going to go ahead and take a look today, we're going to look at some vocab. We're looking at different types of angles in a triangle. And so there's some rules that you probably have heard. We've talked about it already. We're going to make sure we got it down now as we go forward, okay? If you guys will please go ahead and highlight this first definition about the interior angle of a triangle, and then also this particular theorem about the sum of the measures of the interior angles of a triangle. If you'll please add this to your notes, that if I add any triangle, I'm going to add all the inside angles and I should equal 180 degrees, okay? So if you had a triangle and we numbered them 1, 2, and 3, I should be able to use this particular theorem, okay? So a pretty basic one in geometry, taught a little bit in Algebra 1 if you got it. But stuff that we have done so far this year, talked about, so now we got to solidify that, keep this locked away, all right? So the book here is going to ask us to be able to kind of think a strategy out how to find some missing angles in a triangle. I'm not going to have you write that down just because of the brevity of it. And I'm sorry, I got to stick to my word here. What I had you write down was this, if you didn't see it. I can't tell if it's recording off the screen or not, so stick with me. But that's what I had you write, which I remember here. Okay. All right. So taking a look at this triangle down here, I think that we all could see that it's been divided into 2 triangles. And then, but that means each triangle in itself is going to be equal to 180 degrees. So I got it, strategy-wise, I just got to see what they gave me. The easiest angle right now probably is to find angle 2 because it's got 2 other angles with it, all right? So if I know that all 3 angles are supposed to equal 180, I could take the 2 that I have, so 57 and 71, add them together, so I think I get 128. I could take those now and subtract them from 180 degrees, and it will get me angle 2. So when I subtract that, I think I get 52 degrees. Okay, so that's angle 1. Or I'm sorry, angle 2. Okay. Now, the other thing that kind of happens with this is kind of some rules that we need to remember. We need to remember what a linear pair is. And later on, we're going to need to remember what vertical angles are. Okay. Linear pair means 2 angles that add up to 180. Vertical angles are going to be equal. So if I go and look here at angle 1, well, 1 and 57 make a linear pair. And remember, a linear pair is 180, like we just said. So I think I could take that 180 degrees for the line and subtract 57 from it, and I get 123 for angle 1. Okay. So we're using what a triangle equals. We knew that a line equals 180. We're just taking stuff and mashing it together. Now that I've got angle 1, I think I should be able to take angle 1 and the angle 28. And angle 1 was 123. The other angle is 28. If I add those 2 together, I should be able to subtract them from 180 to get angle 3 now. Okay, so playing some games. So if I add those together, I get 151. And if I subtract that from 180 degrees, to get 29. So angle 3 equals 29 degrees. Okay. All right. So a very basic question that shows up a bunch. We give you a little bit of information. You take some of the rules that you're supposed to know, apply them, and find some missing angles in this case. Okay. If we kind of skip the rest of this here, because this is just kind of asking us how do we go about doing that. Here we're supposed to write down what angle measures we got. Okay. If we go here, we're going to look at another type of rule that we can use. If you're looking at this, you should see that angles 1 and 2 are vertical angles. So angles 1 and 2 are going to be equal. Okay. And they give me over here in this triangle, they give me 2 angles. So I think I'm going to go ahead and add 43 and 74 together and use that to subtract from 180 to find angle 1. So when I do that, I think I get 117. I can go ahead and subtract those two together or from each other. Okay. And here I think I get 63 degrees. So since angle 1 is equal to angle 2, both of them should be 63 degrees. So I can say 63 here and 63 here. So now what I can do, I can use that to get angle 3. They give me the third angle over here of 79. So I could take the 2 angles in that particular triangle, 63, which is angle 2, and 79, and be able to add those together. I get 142, I think, when I get that. So I should be able to take that and subtract it from 180. And I think I get 38 degrees when I do that. So angle 3 equals 38 degrees. Okay. Very basic, pretty straightforward rules we can use here to get what we need to get. Okay, and stuff that you've done before. We have to learn how to dig back and grab that and be able to use different things together. Okay. All right. Okay, another rule that kind of goes with triangles, and if you guys will please highlight these 3 terms, interior angles, which we kind of already talked about. Now we've got an exterior angle to talk about, and then we got something called remote interior angles. That's a new term for me. We used to call this non-adjacent, so not next to. So, you know, sometimes I'll use that. I'll slip up and use the old term. Okay. But basically what it's saying is that if I took a triangle and I extended one of the sides, I create an exterior angle. And we're going to get a theorem. If you'll write this down, there's going to be a theorem that says that 2 angles that were not adjacent or are remote interior angles. Remote or not adjacent means not next to. So angles 1 and 3 are not next to the exterior angle number 4. But I could take the sum of those 2 angles. Oops, sorry, hold on. I could take the sum of those 2 angles and set them equal to the exterior angle. Okay. So I could go angle 1 plus angle 3 equals angle 4. Angle 2 is adjacent to angle 4. It is interior, but it's not remote because it's next to. But remember that angle 2 plus angle 4 equals 180. Okay, because it's a linear pair. And we just learned that if I took all the angles of a triangle and added them together, I'm also going to get 180 degrees. So angle 2 kind of acts like a transitory property thing or transitive property thing with the exterior angle and the triangle itself. Okay. So really important rule. We're going to use it a bunch. You need to know that, right? So this is just a flow chart proof. We're not going to do this, but you know, just taking what they show you here and what's given and what you have to prove. They're just proving that theorem. And if I have angles A and B, it's angle A plus angle B should equal angle 1. All right. And angle 1 plus angle 2 equals 180. And angle A plus angle B plus angle C also equals 180. Okay. Trying to mash all that together and kind of use it, different theorems, and kind of get it together acting as one. Okay. Or not acting as one, but acting in, you know, together. Okay. So if we go down here and we use this A-frame house, they're asking you to look at angle DA, and then I think that's B up there, okay? Well, this angle right here, 12x plus 7, is outside the house, and then they give you these two angles that are actually the inner part of the house, so it's the inside part of the triangle. Those two angles are remote to the exterior angle, 12x plus 7. So I should be able to take that theorem and take that exterior angle and set it equal to the other two added together, okay? So I should be able to kind of put like terms together over there on the side. So I'm going to get 6x plus 61. I'll subtract 6x from both sides. And then I'll go ahead and subtract 7 from both sides. And I can divide by 6. Okay. I can go ahead and plug those back in at times 2. So if I take this x equals 9 and plug it into the exterior angle, 12 times 9 is 108 plus 7 gives me 115 degrees for this outside angle. Okay. If I go and take it and plug it back in at the very top of the house, 6 times 9 is 54, minus 4 gives me 50 degrees up here at the top. Okay. If I check my answer, I want to add 50 and 65, I get 115, and that's what I got for the exterior angle. Okay. Okay, taking a look at this puzzle picture here. If you take a look at this 5x plus 15, that's an exterior angle of the green triangle, excuse me. So if it's outside of it, it's an exterior angle, and 45 and 3x are interiors. I should also be able to take those and set them equal to the sum of the interior angle. Okay. So in this case, I'm going to subtract 3x from both sides. I'm going to go ahead and subtract 15 from both sides. And I'm going to, subtract 15, and I get, divided by 2, I get 15. Okay. So if I plug this back in, I plug 15 back in for 5x plus 15, I'm going to get 5 times 15 is 75. And 75 plus 15 gives me that angle as being 90 degrees. And if I plug it in for 3x, I'm going to get 3 times 15. I'm going to get that angle down the corners being 45 degrees. Okay. All right. Okay, a couple of corollaries that go with this. If you want to highlight these two, please. The key here is the term a right triangle. So remember, a right triangle's got an angle that's 90 degrees. And so that theory is just, or corollary is just saying that the other two angles are called acute. And if I add those together, they should equal 90 degrees. Okay? So we learned about what complementary is a while ago. Okay. This other one not being used right now, but it will be used. But in any triangle, you can have at most, so that means only one right angle or one obtuse angle. You can't have both. Okay, at most you can have those. Okay, so taking those kind of two corollaries here, just really is trying to make our work a little bit easier, which I think most of you like, I hope. If I take a look at this triangle out here on the right, so hopefully you can see it on the screen. If not, check your book. But it's triangle BDC. Okay, that's a right triangle, because if this is right out here, then that has to also be 90. So that means I could take the x plus 8 and the 2x minus 2, and I can now set it equal to 90 degrees. Because remember, a triangle's got to equal 180, but if this is already 90 of it, then by that corollary we just read, those other two have to add up to 90. Okay, so it just makes the numbers smaller. I could add 90 and set equal to 180, but I'm just being redundant there if I do that. If I put some like terms together over here, I'm going to get this. Okay, I'm going to subtract 6 from both sides. I get this. And if I divide both sides by 3, I get that. Okay. If I plug them both in, that x plus 8 becomes 36 degrees. The 2x minus 2 becomes 56 minus 2, which is 54 degrees. And check in, yes, they add up to 90 like they were supposed to. Okay. Okay, same thing with this other triangle, ABF. It's also a right triangle because they show it to me right here at angle B. So I should be able to take the 5 over 4y minus 45 plus the 1y and set those equal to 90. Okay, because they're both acute. They're in a right triangle. They have to add up to 90. Okay. I'm going to do something different. I'm going to take this 5 over 4 and change it to 1.25, make it hopefully a little bit easier. So if I add that with the 1y, I'm going to get 2.25y, and minus 45 equals 90. Okay, I'm going to add that 45 to both sides. And I'll divide both sides by 2.25, and I get 60. Okay. And if I go and plug that back in, I'm going to get that this angle y is 60, and the angle up top should be, if I plug it in, do my math, I'm going to get 30 for this angle with the fraction at angle A. Okay. And 30 plus 60 equals 90. All right. Good there. So they're doing all the work here for you. I'm trying to conserve time and space. I do that. Okay. Okay, this particular question here, kind of doing the same thing a little bit. At least this triangle ABC, it's got a right angle right here. Okay. So that will let me take the 9x minus 8 and the 2x minus 1 and add them together. Okay, I'm going to get like terms together, so I'm going to get this. And I'll add 9 to both sides, so I get this. And I could take and divide by 11, and I get 9. Okay. Now over here on the side, they want me to go ahead and write all these, so I think I'll do that with this one. If I take that 9 and put it in for angle A up here, I'm going to get 9 times 9 is 81. And 81 minus 8 should give me 73, I believe. And that's angle BAC at the top. If I put it into the 2x minus 1, I'm going to get 18 minus 1, gives me 17, and that's angle ACB or BCA. Okay. All right, now, they're not, in the other triangle, DCF, they're not telling me that anything's 90 degrees, so I can't assume that. But if I found this was 17 degrees, then this needs to be 17 degrees because of vertical angles, okay? So I got to go and just assume, hey, I got a triangle, all the angles equal 180. So I need to take these 3 angles here and just add them together equals 180, okay? So we're going to go 17 plus 9y minus 1 plus 11y plus 4 equals 180. Okay. And I did find angle DCF. I used the vertical angle thing, so I'm going to put that up there in case I forget. Okay, I got a lot of stuff here to put together. Let's put the y's together first. 9y and 11y is 20y. I got 17 minus 1 is 16, plus 4 is 20. That equals 180. Okay. I can go ahead and subtract 20 from both sides. I get this. And I'm going to divide both sides by 20. I get y is equal to 8. Okay. So I got these last 2 angles I got to go find. I'm going to go find the 9y minus 1, which is CDF. 9 times 8 is 72. 72 minus 1 gives me 71. And 11 times 8 is 88. And 88 plus 4 is 92. So it's a good thing I didn't assume that angle down there was 90. I know it looks like it, but can't assume that. Okay, that's those, all these problems we've done are pretty much like a test question. Really important that I hope you study and go back and look at these, okay? All right, I believe I am done. Okay, so thanks a lot, you guys, for doing a good job. The assignment will be put up on the board for you that goes with this. Please look at this. If you got any questions, come and see me and make sure we get some extra help and get caught up. Okay, thanks.